Algebra 2, Set 1, Polygons, Triangles, Transversals, and Proportional Segments. Okay, so the first thing we're going to talk about are polygons. Poly comes from Greek poly meaning many, gon meaning side. So polygons have many sides. So we can have triangle, which has 3 sides, quadrilateral has 4, a pentagon has 5 sides, a hexagon has 6, an octagon has 8, and here's another example of an octagon. Now, some of these shapes aren't what you would traditionally call the shape, like the first the hexagon doesn't look like what we usually consider a hexagon in the first octagon. And we'll talk a little bit more about why these are considered polygons. Okay, so the definition of a polygon, it is a simple, closed, flat, straight line sides geometric figure. Okay, so here are some examples of shapes that are not polygons. Okay, this is not a polygon because it crosses over itself. Same thing here. This is not a polygon because it is open. And this is not a polygon because it is curved. Okay, so here we have examples that are polygons. Of course, you can recognize the triangle and the rectangle, and then we have some other shapes. This one with the tick marks on it is what we consider an equilateral. All of the sides have the same length. And this one we would consider equiangular because all of the angles are the same angle, if you can excuse my poor drawings. And then this figure has a concave side, so and we'll talk about concavity. So polygons always have the same number sides as they do angles. So a 3-sided figure has 3 angles, a 4-sided figure has 4 angles, and so on. Okay, so now we'll talk about what it means to be concave. A concave figure has an indentation in it, and a convex figure has no cave, no indentation. A quick test to see how you can test to see whether something is concave or not is if you pick any 2 points inside the figure. If you can draw a line that goes outside of the shape, then it is concave. If you draw a line and it stays inside the shape for any 2 points that you pick, then the figure is convex. Okay, a regular polygon, all the angles have equal measure and all the sides have equal length. So, in the book, there are drawings of regular polygons. This is a regular pentagon, and this is an irregular pentagon. This is a regular heptagon, and this is an irregular heptagon. So in the regular figures, all of the angles are the same and all of the sides are the same. If it's irregular, that's not the case. Okay, so a polygon's name tells how many sides it has. So triangle has 3, a quadrilateral has 4, pentagon has 5, hexagon has 6, heptagon 7, octagon 8, nonagon 9, decagon 10, undecagon 11, and dodecagon 12. If you don't know how many sides it has, or if it's just a large number of sides, we call it an n-gon. So if it has 143 sides, it's a 143-gon. Okay, two vertices that are next to each other are considered consecutive vertices. You can tell that they're consecutive because they consist of the 2 endpoints of a segment. If you have 2 sides that are next to each other, we call them consecutive sides. And this is a diagonal. I'll draw another figure and show you diagonals of that figure. A diagonal connects 2 non-consecutive vertices to each other. Talking about triangles, this is a right triangle, this is an obtuse triangle, and this is an acute triangle. A right triangle has exactly one 90-degree angle, An obtuse triangle has exactly one angle that's bigger than 90 degrees. An acute triangle has all three angles less than 90 degrees. The sum of the angles in a triangle is always going to be equal to 180 degrees. Okay. If you have a triangle where one of the angles is 80 degrees and the other angle is 70 degrees, we know that the side opposite the 80-degree angle is going to be longer than the side opposite the 70-degree angle. Length C is bigger than length B because 80 is bigger than 70. The length of the side always corresponds to the opposite angle. So the greatest angle is opposite the longest side. So you can see here, this angle is bigger because it has a longer side, whereas this angle is shorter because it has a shorter side, and vice versa. So the smallest angle is opposite the shortest side. Okay, so now we'll talk about scalene triangles and isosceles triangles. A scalene triangle has all three angles that are different, and therefore all three sides are different. An isosceles triangle has exactly two sides that are the same and exactly two angles that are the same. And again, the angle always matches the opposite side. We know that this third angle in the scalene triangle has to be 40 because the measures of the angles have to add up to 180 degrees. So again, a scalene triangle has three different angle measures, three different side lengths, whereas an isosceles triangle has two equal sides and two equal angles. Okay, an equilateral triangle has all three sides that are the same and all three angles are the same. And the angles are always going to be 60 degrees, 60 degrees, and 60 degrees. So for our first example, find x and y. We can see that we have an isosceles triangle. We know, sorry, I didn't fill in the rest of the problem. We're given that one angle is 50 degrees. So we can see that if this angle is 50 degrees and the other opposite angle, or the opposite side, matches the second side. Sorry, let me start that over again. So if we know that the measure of this angle is 50 degrees, then we know that this angle has to match it because of the fact that it's an isosceles triangle. So therefore, it has to be 50 degrees. We can find y because the measure of all three angles of a triangle add up to be 180 degrees. So y has to be 80 degrees. Okay, so for this problem, find x and y. So the first thing that we can do is we know 150 degrees plus x equals 180 degrees because it's on a straight line. So x has to be equal to 30. Once we know that x equals 30, we can take 30 plus 40 plus y, and we know that equals 180 degrees because they are the inside of a triangle. So y has to be 110 degrees. Okay, next problem. This triangle is an equilateral triangle. Find angle D. Well, we know if it's an equilateral triangle that all three angles measure 60 degrees. So if the angle opposite or adjacent, if the angle adjacent to 60 is D, then 60 plus D is 180 because they are on a straight line. So D has to be 120 degrees. Okay, so now we'll talk about transversals. A transversal is a line that cuts or intersects two or more lines. So in this case, line T is the transversal. Okay, so if we have parallel lines if a transversal intersects two or more lines that are parallel, and if the transversal is perpendicular to one of the parallel lines, it's perpendicular to all of the parallel lines. Okay, so there's special cases when you have parallel lines with a transversal cutting across. And that is that the large angles are all equal to each other and the small angles are all equal to each other. So if we have 120 degrees as the large angle, then all of the angles are 120 degrees. Therefore, the small angles are 60 degrees and all of the small angles are 60 degrees. And it is true if you have 3 parallel lines, 4 parallel lines, however many parallel lines you have, it's always going to be true. So the large angles will equal the large angles and the small angles will equal the small angles. So we know that the length, or the large plus the small, is equal to 180 degrees. Okay, so find A, B, and C. We have a transversal cutting across parallel lines M and N. So the first thing, 60 plus A is 180 degrees because it's on a straight line. So A is 120 degrees. Okay, if A is 120 degrees, then B is also 120 degrees because they are the large angles. So if B is 120 degrees, then angle C plus 120 is 180. And we can either use 180 plus, or subtract 120 to get 60, or we can just look and see that C is the small angle and 60 degrees is the small angle. Okay, so now we'll talk about proportional segments. When 3 or more parallel lines are cut by 2 transversals, the length of the corresponding segments of the transversals are proportional. So the main point here is that corresponding segments are proportional. Okay, lengths of the corresponding segments are related by scale factor. So here's what we're talking about. If you have 3 parallel lines that are cut by 2 transversals, then there's a scale factor between 2 and 3 and between 3 and 9 halves. So if we want to know the left to right scale factor, we can take 2 and multiply it by some number to get 3. And that some number that you multiply 2 by is 3 halves. I know 2 times 3 halves equals 3. So in this case, our scale factor is 3 halves. So if I take 2 times 3 halves, I equal 3, and 3 times 3 halves equals 9 halves. If I go right to left to figure out the scale factor, then I would take 3 times something to equal 2. And what that something is going to have to be 2/3, because 3 times 2/3 equals 2. So 3 times 2/3 equals 2, and 9 halves times 2/3 equals 3. Okay, so if we need to find x, the first thing that we need to do is find the scale factor. So the scale factor between 2 and 8/3 is going to be 8/6 or 4/3. We divide the scale factor by 2 to get the scale factor by itself. And then dividing by 2 is the same as multiplying by 1/2. So 8/3 times 1/2 is 8/6 or 4/3. So I know that 2 times 4/3 equals 8/3. So 5 times 4/3 has to equal x. So therefore x is equal to 6 2/3 or 20/3.